All right, excellent. I don't think I've ever had this many people show up for a repeat session before, so that's awesome, very exciting. So thank you for the privilege and honor of your time. Great to have everyone here. Did anyone attend the intro session yesterday and wanted to see it in a second? A couple were here already. So we'll probably do this one a little bit differently because I think there's a lot of questions out there, and I want to make sure there's ample time for Q&A. So I know a lot of people have been asking questions coming up to the booth and all that. So we'll want to make sure those get addressed. So I'll make sure we leave ample time for that. We're going to show you a lot of things as well. One housekeeping note before you leave. There will be people in the back of the room. They have a little card that looks like this t-shirt, and you go down to the DevZone booth down in the exposition area, turn that card in, and you will get said t-shirt. So it's the hottest commodity at Summit this year, and I think this will be literally the only time this t-shirt exists, so it'll be a little thing you can claim, I was there. So good morning. So I'm Todd, this is Aslak, and we're going to go through some of the OpenShift IO stuff. I always like to start actually helping people to understand why we built the product, what motivated it. I probably spent too much time describing that yesterday, so I'm going to go quicker today. That way we can get into it itself. Let me see if I can get next screen. My first advertisement, though, of the day, I'll do one or two advertisements, is Red Hat does have a really awesome developer program. It's completely free. You just got to go to developers.redhat.com and sign up, and you get lots of great benefits in doing so, including the ability to download most of the products that we have, which is great if you want to do development or testing. Good morning, James, on them. You can certainly do so. And we also have a bunch of material, quick starts, things like that, knowledge base articles. These Linux cheat sheets and other cheat sheets that we have proven to be incredibly popular, especially if you've come from a different operating system, if you've been a Windows person or a Mac person, and you're like, how do I just navigate around Linux? What are the command lines? Like, I know dir is my directory command. What's the equivalent in Linux? Things like that. Super, super powerful. So that's the end of the advertising. So just a little bit of the philosophy that led into OpenShift IO and kind of how we went down this journey. It's a journey that started for us, depending on how you do the math, somewhere between 18 months and 2 years ago. A bunch of us had been thinking about these ideas. If you go the math a little bit further and you think about the upstream project in Fabricate that really is a lot of the technology behind OpenShift IO. Fabricate is 4 years old now, James? 4 years. So, but at the end of the day, a lot of what goes into this is a lot of people that have been in this industry for probably too long, like myself and James and others, that we've been constantly thinking about these things, and we don't stop thinking about how to make lives of developers better. I will not bore you with the boring details. I think if you're in this room, you've bought into the notion that every company is a software company by now, right? That the way you compete is through doing innovative things versus the people you're competing with. And most of those innovative things are built upon software. They have a software component to them. And we can see that in the trends out there in terms of where companies are spending their money. They're spending their money on developers, on software, and on services. And the talent that they're hiring, if you're a programmer or you're a data scientist and you're not employed right now, you're probably not looking is why, right? Because the unemployment rate for people in our industry is incredibly healthy. But what's happening is, and every decade or so we see this, that there are some pretty fundamental shifts in the way software is written. That's due to some kind of major underlying sea changes that occur. I started programming in 76, 77, so I've been programming a long time. We did things very different back then. I was not a mainframe guy or anything like that. I was, very much on the PC side of the world. And you built not only apps that were for one person, they took over the whole machine, right? And it was the only thing running in the machine. Then we started getting into multitasking and all that. Then the advent of like client server, and then the web changed everything again. And now we're in this notion where it's partly a technological revolution in terms of containers and people moving to microservice architectures and things like that. But it's also just a philosophy and a methodology approach to software, not building massive monoliths, having that ability to respond quickly to change. If you want to change just one aspect of an application and get that change out quickly because it's going to have a competitive advantage, it's a lot easier to do when you can literally change that one part of the app and deploy it rather than having to get it integrated into some massive thing where you touch it over here and it breaks over there. So changing that requires a lot of changes. That requires not only the approach we take to writing software to change, but even the tools that we have to change. And that starts now getting into why did we start working on OpenShift IO. Lots of scary statistics. Once again, won't bore you with these, but we suck, I think, is what these statistics tell us. As an industry, we are not a mature engineering industry. As a matter of fact, there was some guy that was recently arrested or fined because he said he was an engineer. Right? And I once had a job where I was a sales engineer, and we actually had to stop calling ourselves that because in some states in the United States, oh, you're an engineer? Where's your engineering license? You need to have a license to be an engineer, right? So I was no longer an engineer at that point in time. But we don't have a good track record as an industry of writing incredibly stable, great software. There's this big movement to self-driving cars, which I think is funny. I think the deeper you are in the industry, the more that frightens you, because oh, it's going to work great 98% of the time, but there's that 2%. We had this problem yesterday. This is why I will never get in a self-driving car. So we started the registration process for OpenShift IO yesterday, and people started coming in and registering, and it's great, and we got this mounting list of people that want to use the product, super exciting. But there was a certain class of users who had done other things with Red Hat in the past, had registered for something else in the past, and matched this one specific use case that when they went through the registration process, it was like a collision of SSO, single sign-on, and identity management systems that they were getting an error. Now, that was bad, but that was the edge case of me in a self-driving car being in that one situation where it's oh, I don't know what to do, and it crashes. But the best part about that story is, hey, no one likes to have an issue, especially on registration. But the best part was because we've adopted an architecture where we can quickly respond to change. We identified the problem, we coded the fix of the problem, we had it deployed in 90 minutes, James, or something like that. It was very, very quick turnaround, so that was awesome to see. So how were we able to do that? And James, I'm sure, will have some words about this, but the idea is that we've embraced this notion of being able to respond quickly to change. And we find a couple of things that have been key to that. One is we thought, hey, the more cloud-based you become, the more that you can operate, say, in a browser. And 10, 20 years ago, that was that's not going to be a fun experience. But with the advent of the way the web technologies evolved today, what you can do in a browser, it's very hard to not have essentially a native app experience. Have that experience so you don't have to install anything. And more to the point, we had this great issue yesterday where one of the laptops for the presenter was not playing well with the projector. So he just came over to this laptop that was in the room and logged in, and he had his whole environment. Everything was there. That's a pretty compelling story. He got started instantly on a machine that he had never touched before. We think that's got a compelling ring to it. We do believe that people adopting these build pipelines as a way of really moving towards continuous delivery is super, super important, that you get that immediate sense of your ability to integration, constantly running testing, automate everything. We've got to do our part. We've got to make it easy for you to automate everything. That's one of the motivations behind OpenShift IO. And we can talk about the advantages of that. James will probably show you something that can really show that you can actually take a change request, do some commit, roll it out, and be able to evaluate just that isolated change independent of the rest of the system. And to be able to do that really essentially in production is phenomenal. And then the last thing that we kind of introduced yesterday was this, the OpenShift IO analytics, this notion that we can have this body of knowledge out there. There's a ton of open source code out there that can be analyzed. What can you learn from it, and how can you provide real-time insights from that? So these are the kinds of things we thought about, and that led to OpenShift IO, and this will be the last slide. So OpenShift IO, you will see, kind of looks at the world as a virtuous cycle that we've currently have broken down into 3 phases, and this went from everywhere from being 5 phases to 2 to 6. Like we kept going around and around on this. See, that was not intended to be a pun. But this notion that, essentially you analyze the world around you, you take in input, and that input could be anything. Like anything is valid input. A system that's running right now that's crashing, that's very useful immediate input. A system that's running right now that has high CPU load, that's also an interesting input. But there's other inputs, like from your business, like the number of people that are able to complete a shopping transaction on your e-commerce website. That's a very valid and interesting input. And things like that, right? There's no customer feedback. Sentiment analysis coming in from Twitter, which I'm now becoming very attuned to after yesterday. These are things that you need to be thinking about, and we want people to be able to take in all of these myriads of input and be able to analyze that. You take that analysis, you synthesize it, right? Data is data, but it's only when you kind of like analyze it does it actually become information. You take that information and now you make a plan, right? And that plan is, what are we going to do with it? Where is the most important places for us to be investing? And if you don't do any analysis, you're probably going to make bad choices. We don't want people to make bad choices. But we want people to plan in a way that they're not just guessing, but they actually are verifying these hypotheses they're coming up with. So if you think, oh, if we make this change, that's going to help us get better, shopping conversion from the people that are using our e-commerce website, then measure that outcome. Don't measure something else. And all too often, we measure something else inadvertently. So here's an example of what you might measure incorrectly. You might say, oh, we're getting poor shopping conversion because that button is red and not blue. So we're going to change the color of the button to be blue. Then it gets distilled into some engineering requirement to change the button from red to blue. And so engineering's like, great. We're going to change the button from red to blue, and the acceptance criteria they write is the button is blue, right? And then the button gets turned to blue, that change gets rolled out, and there's high fives all around the room because like, hey, we met the criteria of changing the button to blue. Now, for all you know, maybe your shopping rate conversion went down after that. Maybe people hate the color blue. But you've lost that. Like you had this original hypothesis that changing the button to blue was going to have some business outcome, but you never measured it, right? And that's why I say we live in a world of guesses. We need to move to a world of verifiable hypotheses. OpenShift IO is starting to make that possible. We have a ton of work going on right now where that's kind of the next phase of things you'll see this summer is how we light up more of that up for you. So stay tuned for that. And then lastly, once you have this plan, you now need to go make stuff, right? There's no point in having a plan if you don't do anything. So you go and you make stuff, you write new code, whatever it may be. You get that running. People start touching it, and what happens when they start touching it? You get a whole bunch of more feedback. And what do you do with that feedback? You analyze it, you plan some more, and then you create new stuff, and you keep going round and round. And that's kind of the philosophy of OpenShift IO, at least my philosophy. And I made the slide, so. So with that, we'll do 2 things. So we've got it running over here. This is in my account. Do you want to? Is that okay? That's fine. I really, really wanted to show it to you running on this device, which is my phone. But it didn't play well with the projector. But it does. What you see here and what I would have done on here is almost exactly the same. And what's cool is you can make changes on one screen and they show up on the other, all that jazz. So just imagine you saw that and it was awesome. But we'll go into the product. So this is the product running live over the conference Wi-Fi. So please no BitTorrent transfers right now. That wouldn't help us. We'll go in, we can show a lot of what you saw in the keynote yesterday, but I want to make sure we're kind of delving into the areas that you guys care about the most. So I'll start with that. Is there anything that people are like, hey, Todd, I really need to know more about X. What would X be in that case? Is there an area that people are particularly concerned, interested, confused about? Nothing, really. Oh, see. Yes? The interface where you see the code. So the working on the code, what the heck is that? Is it not running? Oh, it's running. Okay, good. So I have my workspace running, and Aslak's going to go open it. So first of all, you see how quickly it will be for us to get into this interface. So this is Eclipse Che. So Eclipse Che's does anyone remember what it originally started as a project? Was it its own, or did it start from one of the other ones? We'll probably have to look it up. You can look it up on my phone. So there's a bunch of cloud-based open source ones out there. It is not based on Atom, though. It's an IDE, so they all kind of look similar. So it's IDE. It's behind the scenes. It's actually Google Web Toolkit is how the UI is authored. That's obviously pumping out HTML5, JavaScript, CSS. But it is completely in the browser IDE, and that's why I can actually run it. There's an Android phone which has Chrome on it. So when I run Che on this phone, it looks exactly the same, right? And I typically don't run it on the phone. You can, it's kind of hard. But I use a docking station, plug into the monitor in my hotel room, use keyboard and a mouse, and suddenly you wouldn't know that I wasn't on a full desktop. So people get excited about Che. So Che is cool. So it's been a fairly long-running project. There's a number of great contributors on the project. There's a company called CodeEnvy that the leads of the project are at CodeEnvy, and they've put a tremendous amount of work into here. Red Hat has been involved in Che for about a year now. One of the biggest contributions we've done is really in making Che be very OpenShift friendly. So it runs really, really well on OpenShift. So one of the consequences of OpenShift IO as an open source project is, even if you're not ready to adopt OpenShift IO today, but you like Che, if you want to just run Che and you've already bought into OpenShift and you're just looking to run a kind of a cloud-based IDE on top of OpenShift, it'll work there now. Like we've fixed all the little nuances that made it not OpenShift friendly and made it OpenShift friendly. I've already fixed the bug. We'll put the bug back in. So one of the other things that we 110, I think, it has the bug in it. So let's see. That's all. I quickly showed it. So one of the other things that we added to Che was the language server protocol. So this was another announcement we had made about a year ago. And the language server protocol takes an IDE and really says, you know what, IDE, it's not your job to understand languages. Because if we need you to understand languages, and every time we want to make an enhancement to a language or have a new language, we've now got to go to you, IDE, and fix you. We got to augment you. We got to do work in you. And then we got to do that work in this other IDE and that IDE. And it's, if you've ever worked inside the code bases of an IDE, it really should be a form of punishment for major crimes. It's a very awful place to be. So the language server protocol, and it kind of really, people had experimented with this philosophy, this kind of notion of this architecture. I would say Visual Studio Code, the open source Visual Studio project, really made it become a reality. So Visual Studio Code has tons of languages in it, but they're not in it. They're available through these language servers. So the language server protocol says, take the parts that make the language work, extract that out into its own application, its own server, if you will, and then just have the IDE talk some common protocol to that. And once you do that, anything that can talk that protocol can suddenly gain the advantages of that language. So Eclipse Che, we added language server protocol support to it. So now Che, which originally essentially did Java and some other things, mainly like TextMate type things. It now can do many, many languages. And well, what we did is we went one step further and we said, well, wait a minute, we have this great ability to do this, this analysis on code. So this stack analysis where we can say, hey, we're looking at what's in your code, we're looking at what dependencies you've picked up, and we can find issues in them. And we added that in actually as a language server that is able to bring that analysis into Che. And that's why you could see here that we have this red squiggly on this logback package because that version 1.1.10 has a security vulnerability in it. And we can see it. And what was kind of cool about it, first of all, what I love about it is the fact that it doesn't just say, oh, there's an error here, right? Because which most compilers will tell you. It even tells you what to do. It's like, oh, you should use version 1.2.1. And if you're then saying, well, wait, if it's telling me what to do, why doesn't it just do it? We probably will get there soon, right? That is the idea that this is why OpenShift IO is cool, because it's very foundational in some ways. So imagine a world where rather than it telling you, hey, you should go to 1.2.1, imagine if it just said, I'm going to change it to 1.2.1, I'm going to create an independent branch, go test it all out there and put it out for you to peruse and evaluate and give final approval to. Now that is slightly scary because that begins to feel like some of us don't have a job anymore, but at least we got to hit the approve button, George, what was it? The Jetsons, he was a button pusher, wasn't that his job? He was one of the best, though. So there you see that. Now, what I like about the language server protocol, especially the way we've got this implemented, go ahead and go to 1.2.1 just to get rid of the issue. And if we pause a second, nothing happens because 1.2.1 is fine. But if you go back to 1.1.10 real quick, there it goes. So this is happening in real time. That was making a call back to our analysis services that are running in the cloud somewhere in Ohio or wherever they're running today. And that quickly reanalyzed this entire file and came back with, oh wait, 1.1.10 has a security vulnerability. Yes, question.
Okay, so my code lives in my Git repository.
Yes.
Which may or may not be secure and private.
Yep.
Sorry. In the Git repository that may or may not be secure and private. How much is transferred across the wire as far as proprietary code versus checking your analysis for ERETA?
All right, how much? So please, James will be an expert on this.
It's just the POM XML or the package JSON. Okay. So it's literally just your dependencies. It's not your source code, it's just the dependencies.
Now, we might have other analysis that comes in the future that would require more static analysis of the code, but it would be up to you to decide whether you want to enable that feature or not, right? So I want to give you that degree of control. What's happening here, of course, is this code does live in GitHub, but when I'm using it in Eclipse Che, I've got my own isolated workspace. So I actually have essentially a local clone of my Git repo running in my Che environment. And because everything's being persisted to this persistent volume in the cloud, I mean, if we just killed the browser and restarted it, we'd be right where we left off. If I went to another machine and logged in, we'd be right where we left off. And in a really scary example, if I were to log into this workspace on another machine and started typing, it would show up on this screen as I typed it.
Okay, so that means that your branch is out there somewhere in the cloud. Your code is somewhere out there in the cloud, right?
Yes, your code is out there in the cloud.
So, fair enough. Proprietary information.
So the question is,
data bags, encrypted data bags, what are we doing to secure the things that are proprietary, right? Because if it is keeping a temporary version of that branch until you commit it back to the main.
Fair enough. So I'm gonna let James answer part of this.
Let me pass the mic back one seat forward.
So I'm gonna answer the first part, and James is gonna give you the real answer around secrets and all that, I assume, right?
Kind of.
Okay.
Okay. So right now, so OpenShift IO has two parts. There's the shared services, like the analytics and all that kind of stuff. And then we call it the tenant stuff, as in your workspaces, your Jenkins, your builds, and your apps. Right now, all of that is on OpenShift Online. At some point, there might be an on-premise version, maybe, in which case your code would be on your on-premise OpenShift cluster, right? Right now, today, all of your tenants are on OpenShift Online. the first question we usually get in every talk we've done is, when can we have the on-premise version? Which hopefully the answer is soon.
Yes, because the first pushback you're going to get is IT security is going to freak out.
Exactly.
Absolutely.
And really, the way we've made OpenShift IO, where the OpenShift cluster is, doesn't really matter. It's a URL and a token. Right. So it's technically trivial to support OpenShift Online, in which case your source code, your persistent volume is on whatever cluster you want, on whatever disk you want, with whatever security you wish. So it shouldn't be an issue once we support on-premise. And we've designed it so it's trivial to implement. We're just waiting for the green light to do it, like next week.
So now what you need is traveling teams to go talk to the security guy.
Yes.
Developers get it, right?
They do.
Yeah.
Yeah, so absolutely, we'll bring the mic to get this gentleman's question, but my commentary on that is simply this. Yes, people will be deathly afraid of running this because it's in the cloud, just like no one would ever leave their on-premise email, right? So we've been through this transition before, and the cloud tends to win, is what we've learned. But you're absolutely right. They're fair concerns. At the end of the day, you got to make people feel comfortable that the security measures are in place. That's part of our job. We also need, just because Gmail exists doesn't mean Exchange Server went away, right? So there's always going to be the need for both worlds. But a question in the back.
Yeah, my sort of general feedback is this is running in a Docker container using SC Linux, and maybe this sounds a bit sarcastic, but isn't that more secure than most people's MacBook Pro?
So,
anyway, that's just my comment.
Yeah, no, I think that's a very fair comment. So here's a great thing that I think the real point is that when you have one team that's dedicated to operationally making sure this thing is locked down, and you're backing it not just with Linux, but with an SE, a secure variant of Linux like we are, yes, that's probably better than the vast majority of your developers walking around with their laptops. I actually agree with you on that one, most certainly.
I don't think our code I can point because my local Git repository is not exposed to the public.
Yes.
So I don't think it's ready for use with our production code. Right? You're right.
So in terms of, are you saying because your code is only local, it's not anywhere that it's accessible to OpenShift IO?
Correct. My repository is private, right? I can't go and access from the public system.
So there's one thing that's, I think, it probably wasn't really obvious in the messaging that's super important, I think, for people to understand. That day one, OpenShift IO is really going to cater to a very specific segment. We really felt it was important to give back to the open source community. So day one, OpenShift IO is really only appropriate for open source development. And the reason for that is the kind of security measures, the way you want to lock things down, using private repos, those kinds of things just aren't there. They're going to be there really soon. That's kind of the active wave of development that's going on. But I think if anyone that's getting on to OpenShift IO today you're going to be buying into an open source world. Now the good news is most people are going to get on just to kick the tires, understand it, learn about it. So there's going to be a lot of hello worlds or hello vertexes, whatever we call those. We think there's going to be a lot of those, at which point you don't really care where it's safe or secure. But going beyond that, I think the other nice thing is because we have the power of OpenShift underneath this, the way you deal with secrets and things like that, you would do probably in an OpenShifty way, right? There is a mechanism we use it all the time. So as you can imagine, this is a completely open source project. Everything, including the marketing text that makes up the horrific marketing text on the OpenShift IO page, is all in GitHub, right? We've not hidden a single thing. Now, there need to be private keys that are driving all the certificates, the SSO stuff and all that. And we've achieved both because those secrets are actually maintained in the secrets capability of OpenShift. And we would encourage you to get used to how that works. And we'll definitely have tutorials on how to do all that. So there is a way to be completely open source and actually secure at the same time. The question in the back. Bob, you're like Bob Donahue.
Hi.
Hello.
So once you integrate, let's say, OpenShift IO with our on-premise OpenShift, or once you have Kubernetes federated and it can be anywhere, is licensing still going to be free?
So what is it going to cost me when I move it on premise? I can honestly tell you we have no idea. It could be a case that if you've paid for OpenShift, right, and you've bought your OpenShift license, you don't really buy an OpenShift license, you got your OpenShift subscription, it very well could be the case that's all you need. We're toying around with what it should be. Give us feedback, what you guys think is the right answer. Free, okay. Anyone else? So, expensive. There we go, good. So, at the end of the day, the good news is, the Red Hat Developer Group, we only have one pricing model, right? Your email address. Essentially register into our program, become a part of our developer community, and so far, we've only given you stuff for free. That's all we kind of know in my group. If it just becomes a capability of on-prem OpenShift, I say that's not an unlikely outcome. I'm not even sure what would possibly change that. Yeah, I think that's a likely outcome, but we'll see. But it's good feedback. It's overwhelming feedback, I think is what I really mean by that. Cool. Other questions, or we can just go show you something else? Oh, question right here.
So Spring.io has starter code. When you're starting your application, you
Yes.
can go and download your base code so that you can start working on it. Do you have something like that?
Great. Great. So Spring has start.spring.io. What an amazing thing they made, right? And wow, did that do a fantastic job of them building up their community and getting people used to their things. There was a talk yesterday by Andrew Rubinger. Is Andrew in the room by any chance? I thought I saw him walk by. So we have something called, and I'm not sure if it's 100% online right now, but it'll be running very soon, launch.openshift.io. That one of the things it can do is take those Red Hat OpenShift application runtimes. Oh man, I get paid every time I say that one correctly. So it takes those roars, which are things like Vertex and some of the other ones we're promoting, and gives you two experiences. One experience is, I want to build a new application. I'm trying to build a CRUD-style application. I want to use Vertex. I want to bring in a couple other dependencies. Give me a zip file, right? Take the zip file, open it in Eclipse or IntelliJ or whatever you like, and get started, right? Very, very similar to start.spring.io. But also what it can do is essentially say, I want all those things, build me up my app, and it will then deploy it. Well, it'll do two things. It'll deploy it to OpenShift Online so you can immediately start playing with it. You don't even have to get it installed or running on your machine. And it creates a fork of the code base in your GitHub repo. So now you just go to GitHub and you connect your IDE to the new repo, start editing the code, commit and do a push back up to GitHub, and it'll kick off a CI/CD build to OpenShift Online. And it happens, literally walking through the wizard takes seconds, 20, 30 seconds, whatever. And now you've got the demo application not only available for you to modify, but running in the cloud and your own private fork of the code. So that's kind of our answer there. So yes, we've definitely been thinking about that. Thank you. It's almost like, did someone plant? That was a great question. Others? Yeah, we can go through more demo. Yes.
One quick question.
Please.
So how does fabricate.io, the community, differ from?
Let's get James involved for that. James, why don't you come on up here? Grab a mic. I think 2. Yeah, that was too good.
Oh, so I'll use that one. Let me turn this one Okay, so hello everybody. So hi, I'm James. So at Red Hat, everything we do is open source. And the way Red Hat works is every open source project has an upstream community which does whatever the upstream community feels like it should do. And then we have a separate product which focuses on really product stuff like stability, reliability, upgrades and whatnot. So OpenShift IO is the product that you're seeing on the screen. The upstream for all of this code is a project called Fabricate. That's fabric with a number 8 on the end. So it sounds like to fabricate, to make things. It's basically just a short URL we could find and get past legal, which is getting increasingly difficult these days to think of names for open source projects. And JBoss has got some awesome examples of terrible names of projects, by the way. Anyways, yeah, so Fabricate is the upstream open source project for all of this stuff. Now, there's a lot of stuff. Fabricate started off with just one Git repo. It used to be a monolith. We just released the whole thing from one repo. I think now we're about 250, between 250 and 300 Git repos. There's a lot of stuff. Fabricate started off very much, oh, nice website. Fabricate started off very much in the CI/CD space. We were trying to build on top of basically OpenShift and Jenkins, take the best of breed open source stuff, OpenShift and Jenkins, and help people create projects, do CI and CD. Since then, with the OpenShift IO vision, this is now expanded to include an online IDE with Eclipse.js, the Fabricate Analytics, which is doing the red squiggly for the CVE, that kind of stuff. There was an awesome talk yesterday about that, by the way. If you missed it, check out the videos. There's a huge depth to the analytics capabilities for doing things like stack recommendations. If you're using library A and B and C, you maybe want to use D, or you've got a really odd combination of versions there, you maybe want to change them to a more popular, reliable set of versions. There's a ton of value there in the analytics space. There's the UI itself. All the web console is all open source in Fabricate UI. And we've also got all of these integrations with a gazillion different upstream open source projects, like open source Git providers, ChatOps, Gerrit, SonarQube, Nexus.
Do you want to make a comment on opinionated versus unopinionated?
Yeah, we're very opinionated. But we try and be flexible. So what Fabricate has been through this journey, it started off as a monolith, and then gradually we've refactored it into gazillions of these microservices that you can then just opt in and out of. For example, you can just use Jenkins and just Jenkins, or you can use Jenkins and Nexus, or Jenkins and Artifactory. You can add in SonarQube, you can add in Gerrit. You can use ChatOps with, say, Slack or Mattermost or IRC, or keeping it real Jabber, if people still do that stuff. So we've basically got all of these different things that you can add into your development teams to get you productive. So yes.
So here's an important thing, right? So think about if you've got your own product right there, and you're trying to figure out what should we do next in our product, right? And you might say, well, what new features or capabilities do people want? Well, you can't empirically get that information because no one is using the features that don't exist, right? So you can say, oh, everyone's using feature X that we haven't implemented yet. Like, that doesn't make any sense. But we sort of can, right? Your involvement in Fabricate as a community greatly helps, right? Because if we see tons of people like using Slack integration in Fabricate, that's a good indicator to us that Slack integration in OpenShift IO, which is an extremely opinionated installation of this, that really helps us be like, oh, we should, you know, James will say to me, Todd, everyone wants Slack. And I'm like, great, let's go figure that out. But the best part is, it's not then we're like, all right, let's go figure it out. It's like, no, we've already figured it out. It already works. It's already being used by tens of, if not hundreds of thousands of people. So let's just go get it running and test it and be done. So
I should mention as well, OpenShift IO is created using Fabricate, right? And we use Fabricate to fabricate. So like every pull request, every build, every release we do, Fabricate is doing the CI and the CD. So every time I make a code change in, say, the UI or backend service or something, we do a pull request on GitHub. Fabricate then triggers a continuous integration build. Then that triggers a continuous delivery pipeline, and then that does the releasing to staging, pre-production, and production. So we're dog fooding all of the Fabricate stack to build Fabricate itself and OpenShift IO. So all of these pipelines, like we use this stuff every day for everything. So the automation we've been able to build is quite amazing. Like when Fabricate went from 1 Git repo to about 6, it used to take me 1 day to release all 6 projects, because you kick off a build of one project, you'd wait for it to stage to Maven Central and Docker Hub and shit, and then you'd get a new version number, then you had to go to the next Git repository, update the POM to the new version, release that, wait for that to release, and then the next one and the next one and the next one. You're always getting issues with Maven Central or Docker Hub timing out, and you have to retry builds and all this kind of crap. Now we just automate all that stuff. If we do an upstream release of a project, the pipeline will stage it, check it's available and used publicly, then it will generate pull requests on all the downstream projects. The pipeline then waits for those pull requests to merge to master. So those downstream pull requests then kick off CI jobs on downstream projects. So we basically can re-release all of our 250 repositories pretty much automatically by just using lots of automation. When you start doing automation, you suddenly realize how much manual stuff developers have to do these days. We used to all manage versions by hand, right? Every time you do a release, a developer would edit a POM to upgrade a version, right? Which is kind of sucky. Think of how much human life is being wasted by just upgrading versions, right? It's insane. So we have a whole bunch of pipelines that automate this. We kind of want this to be a microservice that you can all use on all your projects, really. Like whenever you have someone in your organization might make a library or a utility, and lots of other teams are using it. Every time there's a new release, they should be generating a pull request on your code, right? Every time there's a CVE or a bug or a patch, we should be spreading these patches out automatically with CI and CD, right? Where you can have human approval if you wish. You may not want to automatically merge to master. You might want to have to +1 it, or you might just be happy to go straight to master. So we need more and more of this automation, basically. So have a look at all the Fabricate stuff, the CI and the CD. I highly recommend people automate everything, right? The more you automate, the quicker you can go, the more microservices you can build. Or let me say it a different way. If you're even thinking about doing microservices, don't even start until you've automated almost everything, right? Otherwise, you will spend your entire life just releasing and doing manual crap like updating versions.
So we're running out of time. But I do think these pipelines are super important. If the one thing you take away from this is learning how to just get started with pipelines, the fact that we give you the template for them in there. I mean, I've build deployment things in the past, and I've never enjoyed it, and I've been in the bowels of Makefiles and really not enjoyed that. But the ease with which you build these things, including the approval workflows, is amazing. I felt bad. This was a build that as we were getting ready and prepping things, probably for the build you actually saw me do on stage yesterday, that was this one. So I had been waiting for 5 days for me to say, go ahead and promote, so I felt bad, so I finally just said, go ahead, you're free to go now. But I find that the ease by which I get this level of sophistication inside of the code that I'm working on is amazing. And these stack reports, they give you this deep insight into those recommendations that are coming out of the recommendation service, I just find to be unbelievably powerful. Here you see the recommendations, right? That it's like looking at all my dependencies, doing a deep scan on them, finding things that I need to know. Some of the recommendations you see here are updating to different versions. If I scroll down here, it might tell me whether I'm behind the latest version or not. Are there any security vulnerabilities? What licenses are being used, right? So think about that. There are a lot of companies that are afraid of star GPL star, as we like to say, right? They don't, I don't have a problem with GPL code, but your company might. But here's the thing. You're writing an app, and you're like, oh, wow, I really wish we could make, this part of the text, maybe do some weird graphical wavy thing. Oh, great, I saw a library that you just pull it into Angular, and, it does that. Just pull it in your Node package. Great. But here's the thing. How many dependencies does that thing have, right? And I've pulled in, I just want to do one simple thing, and the tree of dependencies can be enormous. And what if deep in that tree is something that was GPL licensed, or worse, doesn't actually declare a license? Because that may be even the worst place to be. And when you have something that doesn't have an explicit license on it, you honestly don't know legally where you stand with it. So being able to see the licenses that are being used is super powerful, I think. That could be a way where you can, like, that's a good reason to deny promoting this out. Like, oh, we can't put that out there. There's, some XYZ license that we don't believe in. So I love that, and I love the fact that you don't have to deal with the recommendations right away, right? You can literally just say, let's just add that to the plan, right? And then it goes and adds to the backlog. These, there's a URL issue on that one. That was my bad. And wow, I really...
The other thing that I think is really important, we want developers to be productive and fast and get loads of stuff done and deliver real business value. Development is really hard, right? There's so many things that can go wrong. What's very common right now is developers, for example, use a Windows laptop. They're testing on Windows and then deploying on Linux, right? Or you're using a different version of Linux, or your laptop's using different software stack. What's really important about all the OpenShift IO stuff is everything you're doing from design, coding, debugging, testing, building, running, everything is all using the same Docker containers on the same OpenShift platform. So you're always testing on production, like, well, not production. You're testing on the production platform all the time, right? You've never got that disconnect with, it works on my laptop, but it doesn't work in production, right? You're always on the same stuff as production, which is really, really important, right?
It is.
You should never test on Windows or your Mac, right? You're just wasting your time. Who cares if it works on Windows? It is of no relevance. All that matters now is stuff works in Docker containers on Linux. That's all we really care about, right?
So we're out of time, and I want to make sure people get a chance to get their T-shirt, ticket, and all that. Just one last thing. So this was like one of those recommendations. What I love about this recommendation is that it's got one issue in it, and that'll be obvious in a second. But it is basically telling me what to do, what change I need to make, what file to do it in, what repo that came from. And right now the line number is wrong, so that's a bug that we're addressing right now. But as soon as we get the line number right, we're going to make it so in here there's a button right next to it, or a link right next to it, where it says, hey, go make this change, and you just click it, and then as soon as you click it, you will then be here, right on the line number, ready to make the change, right? And then furthermore, we're going to make it so it just does it for you and says, hey, I made that change. What do you think? Does this look good, right? I've already tested it. I've already deployed it out to an isolated environment so you can see what I did, and that's where we really want automation to really kick in, and that's why what OpenShift.io day 1 is great, but day 10 is going to be better, and day 100 is going to be amazing. Yes. But we're out of time, so thank you very much, everyone. Have a great day, and we'll be chatting.